Hello, you are most welcome. I'm teacher Ivan from Woona Educational Services. Today we shall be looking at the density of mixtures. However, before we continue, I kindly request you to subscribe to all our YouTube channels from Woona Educational Services, which include Woona e-learning platform, Woona Kids platform, and the Teacher Ivan's online class. Otherwise, don't forget to hit the notification button so that whenever we have new videos, you get notified. Thank you. Density of mixtures. What is a mixture? It could be the combination of two or more substances that don't react chemically. We can have examples of mixtures such as milk and water, sugar and water, salt and water, among others. Now, suppose we have two liquids, X and Y, of masses mx and my, respectively, having volumes Vx and Vy, and are mixed to form a solution. Then, the density of the formed solution will be given by density of the mixture, which equals to the mass of X plus the mass of Y over volume of X plus volume of Y. That means that the density of a mixture is given by total mass of the individual components over total volume of the individual components. That is, if we have a solution of sugar and salt, to get the density of that solution, we shall have to get the mass of the sugar plus the mass of the water over the volume of the sugar plus the volume of the water. And therefore, it gives us a conclusion which says density of a mixture is given by total mass of the individual constituents over total volume of the individual constituents. However, since we know that density equals to mass over volume, therefore, sometimes when calculating or when given calculations, they tend to leave out the mass. And therefore, it is upon us to determine the mass and use it to find the density of the mixture. This is what I'm talking about. We can be given density of the individual substances that make up the solution, density and volume without mass. So when you are given density and volume of the individual substances, then you don't need to ask for mass. Otherwise, we shall use our formula. We know that density equals to mass over volume. Therefore, mass is given by density times volume. And instead of writing mass, we shall write density times volume. That is, if we are given density and volume of the individual substances that make up the mixture. That is, Our density therefore will be density of liquid X times its volume to give us the mass of liquid X plus density of liquid Y times its volume to give us the mass of Y over the total volumes. And after looking at how we find density of mixtures, let us look at some calculations involving density of mixtures. Calculations on density of mixtures. Number 1 says liquids M and N are mixed to form a solution. If the density of M is 0.8 grams per cubic centimeter and its volume is 100, so we have, let us summarize, we have the density of M as 0.80 grams per cubic centimeter. We have its volume, that is volume of M, as 100 cubic centimeter. This one is mixed with the liquid N of density 1.5 grams per cubic centimeter and of volume 300 cubic centimeters. The question is, find the density of the solution formed. So we have two liquids that are mixed to form a solution. In this question, we are not given the masses, but we are given the individual densities and the volumes of these two liquids. Therefore, we know that density of the mixture is given by mass of liquid M plus mass of liquid N over the volume of M plus the volume of N. However, we are not given the masses of M and N, but we can easily get the mass from density equals to mass over volume. That means that mass equals to density times volume. So we have the individual densities and volumes. We can use this to find the masses. That is, therefore, we shall say density of the mixture equals to, where we have mass, we shall substitute with the density of M times volume of M plus density of N times volume of N over the volume of M plus the volume of N. Hence, we substitute for density of M, which is 0.8 times its volume, which is 100, plus the density of N, which is 1.5, times its volume, which is 300, over 100 plus 300. Hence giving us, this is 80 plus, that will be 450 over 400, hence giving us 125, this will be 300. This will be 530. That is 80 plus 450, 530 over 400. Hence giving us 53 over 40. Which is 1.325, and this will be grams per cubic centimeter. So that is how we shall get the density of mixtures. Let us look at our next example. Our example 2 says an alloy is formed by adding 500 grams of element P of density 5 grams per cubic centimeter to 400 cubic centimeter of element Q of density 4 grams per cubic centimeter. We are supposed to calculate the density of the alloy. An alloy is a mixture of 2 or more metallic substances. So we have 2 elements that make up this alloy. We have element P, whose mass, we have the mass of P as 500 grams, and it has a density of 5 grams per cubic centimeter. Then element Q has an unknown mass. It has a density of 4 grams per cubic centimeter and a volume of 400 cubic centimeter. Now, in our question, for element P, we are given the mass and the density, but we are not given the volume. Then for Q, we don't have the mass. However, we have the density and volume. That means that for us to find the density of the alloy, we must get the mass of each element and their respective volumes. So for P, we have the mass of P as 500 grams, but we don't have the volume of P. However, from density equals to mass over volume, we can now get the volume as mass of P over density of P. Hence giving us 500 over 5 grams per cubic centimeter. Hence giving us a volume of 100 centimeter cubed. So that is the volume of P. Now we have the mass of P and the volume of P. For Q, we must get the mass. Still, from density equals to mass over volume, hence the mass of Q can be given by density of Q times the volume of Q, which is 4 grams per cubic centimeter times the 400 cubic centimeters, giving us 1,600 grams. Now that we have the masses and the volumes, therefore we can now get our density of the alloy. So density of the alloy is given by mass of P plus mass of Q over volume of P plus volume of Q, which is the mass of P is 500 grams plus the mass of Q, which is 1,600. They are all in grams, over the volume of P is given as 100 plus the volume of Q, which is 400. These are in cubic centimeter, hence giving us 500 plus 1,600 gives us 2,100 over 500, hence giving us the density of the alloy as 2,100 over 500. We reduce, that gives us 4.2, that is grams per cubic centimeter. So that is how we shall get the density of the alloy. This was a bit tricky because we had to get the volume of P and the mass of Q. So that is how we shall work out such problems. Otherwise, that will be for today. We meet next time. But please don't forget to subscribe and hit the notification button so that whenever we post, you get notified and we learn together. Otherwise, thank you. See you next time.